Alright guys, so my name is Miss Evans. I'm student teaching right now at Norman High. Miss Evans, yes. And I'm teaching geometry. But I thought we were going to go back and do an algebra problem because my students are always asking me, when am I ever going to use math in real life? So we're actually going to use a problem that I've used when I was working. So every job you're going to have to be able to maximize your profits. It doesn't matter if you're working in a mom and pop store or a Fortune 500 company, everyone wants you to be able to maximize profits. So the problem we're going to work with is we have an oil refinery. So we have this oil refinery. For every 1 gallon of oil that you're going to produce 2 gallons of gasoline. So we have some restrictions on how much we're going to produce. So we've looked at the demands for next year, and I know I'm going to need to produce at least 3 million gallons a day to be able to have enough oil for the winter. So I need at least 3 million gallons a day that I have to produce. Okay, at the same time though, I can't have more than 6,400,000 gallons of gasoline per day. So I have to have no more than 6.4 million gallons of gas. Okay, so I know that if I produce enough oil and gas at these numbers, I'm going to get $1.90 for every gallon of gas, and I'm going to get $1.50 for every gallon of oil. So I want to figure out, is there some way I can find out where I can maximize my profits? Is there one number of output that I'm going to have the most amount of profits with the least amount of work? So what we're going to do is we have 3 constraints, and for each one we're going to write an inequality about what this one's saying. So I need at least 3 million gallons of oil and no more than 6.4 gallons of gas. So we're going to call X gas, and we're going to call Y oil. So no more than, or at least 3 million gallons of gas. So Y has to be greater than or equal to 3 million. Okay? Because at least means greater than or equal to. Does that make sense? So for this one, I can have no more than 6.4 million gallons of gas. So X has to be less than or equal to 6.4 million. But that's not the only constraint that we can have for X. Can I ever produce a negative amount of gas? Am I going to produce negative 20 gallons of gas? No, that's not going to make sense. So I have to have, X has to be at least greater than 0. Even if I don't produce anything, that's still okay, but I can't produce negative gallons of gas. So these are my 3 constraints that I have. Now I want to see what are my revenue. How much am I going to bring in? So to find my revenue, I'm going to do $1.90, so 1.9 times X, plus 1.5 times Y, and that's going to be how many gallons of oil plus how many gallons of gas, and that's going to be how much money I'm bringing in. So to figure out what that magic number is of how much I need to produce, I'm going to draw a graph, and I'm going to graph my inequalities. So this is going to be gallons of gas, and this is going to be gallons of oil, and these are both in the millions. So I have Y is greater than or equal to 3 million. So I'm going to draw my line, Y equals 3. So I have to have more than this. I have to produce more than that amount of oil. So my gas, I have to create less than 6.4 million gallons. So I'm going to draw my line, X equals 6.4. So I have to create less than that amount of gas. So at the same time, I have X equals 0, so that's my X-axis. So I have to have above this and over and less than this. We also said that for every gallon of gas, or a gallon of oil, I'm going to create 2 gallons of gas. So I have 2, so for every 2 gallons of oil, I'll have 1 gallon of gas. So if I do it like this, 1 gallon, and for all the gas I'm making, I need to create twice as much oil to have the same amount. But I'm going to create at least that much gas. So I have 2 gallons of oil is less than or equal to the amount of gas that I'm creating. But I want to graph this. So I'm going to get y by itself. So I have y is less than or equal to 1/2 gallons of gasoline. So that's my last constraint. So for every gallon of gas, I have a gallon of oil, I have 2 gallons of gas. So when I graph this line, it has to be less than this line. So I have to have more than this much oil, less than this much gas, and it has to be lower than my line, y equals 1/2 x. So it's going to be somewhere in this region. That's my magic number, is somewhere in that region. That's my feasible area, is what it's called. So in order to find out what that magic number is, put into my revenue equation, we're going to figure out what the corners are. Because there's a mathematical property that says one of these corners is going to be my maximum amount of profit. So I'm going to look at what my 3 corners are. If I look at this corner right here, I have the line x is 6.4 and y is 3. So my first point is 6.4 and 3. For my second equation, I have right here, I have y equals 1/2 x, and my other line is y equals 3. So I'm going to plug y equals 3 into that equation. I have 3 equals 1/2 x. Solve for x, and x is equal to 6. So my next point, right over there, is going to be 6 and 3. So now I want to find what this last point is. So I'm at the intersection of y equals 1/2 x and x equals 6.4. So I'm going to plug in my x. So I have y equals 1/2 of 6.4, and I find that y is 3.2. So my last point is 6.4 and 3.2. So now I have my 3 points, and one of them has to be my magic number. So I'm going to look at them. 6.4 is the greatest of all 3 of my x's, right? 3.2 is the greatest of all 3 of my y's, right? So since those are both the biggest number, that has to be the answer. If you didn't see that, you could plug all 3 of them into your revenue equation, and you can find out how much revenue you're going to make for each. So here's my revenue equation. Revenue is 1.9x plus 1.5y. So I'm going to plug in those 2 numbers. So I have revenue equals 1.9 times 6.4 and 1.5 times 3.2. And I get my total revenue to be 16.96 million. So that's the most amount of money I can make. So I need to produce 6.4 million gallons of oil every day and 3.2 million gallons of gasoline every day. If I produce more than that, then I'm going to be losing money. And if I produce less than that, I'm going to be losing money. Does that make sense? You can use the same equation to find out how to minimize costs. So if I want to minimize the amount of costs I'm going to make, I can use similar constraints, and I can figure out how much my costs are going to be. So say, pretend this was a minimizing cost equation, I would use my smallest point to find how much I'm going to use to minimize my costs. So at some point, it makes more sense to stop working than to keep on going, because at some point you're going to lose money. Does that make sense? So sometimes working for 4 hours a day is a lot better than working 6 hours a day. So that's my problem.